Hello everyone. Let's begin with a simple question. How do we power our homes, our schools, our vehicles, and even the phones in our hands? The answer lies in the different sources of energy available to us. A good energy source must be easy to use, economical, safe, and ideally sustainable. Some come directly from nature like sunlight, wind, or water, while others are man-made like coal and petroleum. So today, let's explore where our usable energy really comes from. Now, sources of energy fall into two main categories, renewable and non-renewable. Renewable sources like sunlight, wind, and water can be replenished naturally and don't run out quickly. Non-renewable sources like coal, petroleum, and natural gas are exhaustible. Once used, they're gone. Think of it like this. Renewable energy is like refilling your water bottle from a running stream, while non-renewable energy is like drinking from a fixed tank that will eventually empty. This distinction is crucial when we talk about sustainability. Let's talk about the most widely used sources, fossil fuels. Coal powers electricity plants, petroleum fuels our cars, and natural gas cooks our food and heats our homes. They are powerful and convenient, but they come with a heavy price. They emit carbon dioxide and other pollutants, contributing to global warming. Imagine fossil fuels as an old but dependable engine. It gets the job done, but it pollutes the air and eventually wears out. That's the dilemma with these sources. On the brighter side, renewable sources are like nature's gift that keeps on giving. Solar panels capture sunlight and turn it into electricity. Wind turbines convert the motion of air into power. Dams store water at height and use its potential energy to generate hydroelectricity. These sources are clean, endless, and eco-friendly. But they also depend on location and require significant setup costs. For example, solar panels don't work at night, and hydroelectric plants need suitable rivers and dams. Still, they represent the future of energy security. Beyond the obvious ones, there are some fascinating alternative sources. Biomass uses organic matter, like crop residue or animal dung, as energy. Geothermal taps into the heat of the Earth's crust. And nuclear power, through fission of uranium or thorium, delivers massive amounts of energy from a small amount of fuel. But challenges remain. Nuclear power, for example, requires careful handling of radioactive waste and strict safety systems. It's like using a sharp knife, extremely useful but dangerous if mishandled. Let's solve a real-world problem. Suppose we have a solar panel with an area of 2 square meters. The average solar flux is 1000 watts per square meter and the efficiency of the panel is 15%. How much power does the panel deliver? We use the formula power equals area multiplied by intensity multiplied by efficiency. Substituting values to multiply by 1000 multiplied by 0.15. That equals 300 watts. So, even though 2000 watts of sunlight fall on the panel, only 300 watts are converted to useful electricity. This shows why efficiency matters so much in energy sources. Let's wrap it up. Energy sources are the foundation of modern life. They come in renewable and non-renewable forms. Fossil fuels dominate today but are finite and polluting. Renewable sources like solar, wind, and hydro are clean and sustainable, while nuclear and geothermal offer large-scale power with their own challenges. The key lesson: a good energy source must be safe, reliable, economical, and sustainable. Our future depends on moving towards renewables and using energy wisely. I hope you now understand not just where our energy comes from, but also why choosing the right source is so important. See you in the next session with another exciting concept of physics.